Hello everyone, please watch this video to get the solution for your test of A.1, A.2 and A.3. If you have not solved this worksheet, please solve it first and then check the solution. So question number 1, what is the best estimate of the acceleration of the object? The mass is given to you and it is falling vertically through the air, right? Now drag force acting on. So we know that if an object is falling, the weight is acting in the downward force and the drag force is acting in the upward force, right? So the net force can I write down, that is 8 into 10. Let us take the G as 10 for easy calculation, minus drag force is 60. So this is how much? 18 minus 60 is 20, and F net is more mass into acceleration. So acceleration will be 20 by 8, which will be 2.5 meter per second square. Okay, so option B is the right answer. Now for second question, if you see, they are asking for a translational equilibrium by three coplanar forces of magnitude 3, 4 and 5 Newton. We have to see which statements are true. Now equilibrium means the net force is 0. So option number 3 has to be correct. So option number A I already read. Yeah, it will be incorrect. Now we have to see which one is true, first or the second. All forces are perpendicular to each other. If they are perpendicular to each other, then they may not be equals to 0. The F net will be there, some forces, the net force will be there. So this cannot be the case. Now they cannot act in the same direction. Yes, if they act in the same direction, what are the possibility? 3 plus 4 and 5 here. So this is not equals to 0, so that is not possible. So 2 and 3 are correct. So option C is the right answer. Okay. Now question number 3. An object of mass 1 kg thrown downwards from a height of 20 meter. The initial speed of the object. So U is given to me as 6 meter per second initial speed. The mass is given to me as 1 kg and it is thrown from a height of 20 meters. So it is thrown from a height of 20 meter with an initial velocity of 6 meter per second. The object hits the ground at 20. So this object hits the ground at 20 meter per second. Assuming G as 10, what is the best estimate of the energy transferred from the object to the air as it falls? So this is nothing but the loss in the energy, right? So initial energy is what? So I can say the energy transfer is equals to what? The energy transfer is equals to the loss, the initial kinetic minus final kinetic. That is, will be the energy that will be transferred to the air, right? So initially I have kinetic energy which is half m6 square plus mgh as well, which is at a height of 20 meter, right? So I have mg into 20. So this is my what? This is my initial energy minus, when it reaches the just before hitting the ground, the height will be 0. So I can say only kinetic energy, which is half m 20 square. Now when you calculate this, I can take mass as common. So this is 36 by 2 plus 200 minus 400 by 2. Mass is 1 kg, so it will not have any effect. 36 2 by 2 is 218 minus 200. So the answer is 18 joule. Okay, so I hope it is quite clear. So option B is the right answer. Question number 4. A car is driven from rest. Okay, so initial velocity is rest. Along a straight road, the car engine exerts a constant driving force. Friction and air resistance are negligible. How does the power developed by the engine change with the distance traveled? Now, power is equals to force times velocity, right? And if there is a constant driving force, it means there will be an acceleration. Some acceleration will be there because it is at a constant driving force, not constant velocity. And velocity is what? Force into displacement upon time. So if you look at this question, we have to find out the relation of the power with respect to the displacement. So power versus, so force is constant with respect to time. So if I want to draw the power versus displacement graph, it will be not directly because displacement is not increasing, the velocity is not constant, velocity is increasing as the acceleration is constant. So velocity is increasing at a continuous, so displacement will be, if velocity is increasing, okay, so displacement versus time graph is non-linear, right? It will be like this. So power versus displacement will also be non-linear. It is not linear, guys. Acceleration is there, velocity will increase, so displacement will not be linear with respect to time. It will be a curved nature. So option D is the right answer. Question number 5. An object of mass 2m moving with a velocity 3v collide with a stationary object of mass 4m. So the best way is, this is 2m moving with 3v collide with 4m. So this is 4m, this is 2m. This is before collision. The object sticks together. After the collision, what is the final speed and the change in total kinetic energy? So applying the principle of conservation of momentum, this is 2m into 3v moving all in the same direction. This is positive, right? This is the momentum before the collision. It should be momentum after the collision. After the collision, both the masses stick together. So total mass is 2m plus 4m into common velocity v, that we have to, let us say, v dash. So 3 times 2 is 6mv is equals to 6m v dash. 6m and 6m gets cancelled, v dash is equals to v. So there is no change in velocity. So option C and option D are incorrect. Now we have to see change in kinetic energy. So change in kinetic energy is final minus initial. So final is half, total mass is 6m into v square minus initial is half, initial mass is 2m into 3v square. So this will be 3m v square and minus this will be 9m v square. So 3m v square minus 9m v square, there is a loss of kinetic energy. So you can say, sorry, it's the gain in kinetic energy. So we can say 6m v square. The change is 6m v square. Option B is the right answer. Okay. Now question number 6. Look at the graph. So the graph is given to you versus displacement versus time graph, and the question is asking you the average speed and the average velocity of the object over 10 second of the time interval, guys. Okay, so we know that displacement versus time, the total area under the curve will be what? Average speed and average velocity. So displacement versus time, if I want to find out the, for the first time, so this is displacement, guys. So displacement means the shortest path, so it goes and it comes back. So for finding out displacement, what sorry, average velocity, I will use the displacement will be, final displacement is 8 divided by 10, which is 0.8, and average speed, I will take the total distance, which will be 10, and then moving back to 8, to 10 plus 2, which is 12 by 10, which is 1.2. So option C is the right answer. Okay, quite easy, just a basic understanding of the distance and displacement. Now question number 7. Now this is very good question, guys. Now when we are drawing a free body diagram, guys, we don't draw centripetal force, we don't draw centrifugal force. If you know, centrifugal is an imaginary force, it is not a type of force. Okay, so when an object is suspended like this and it is traveling, accelerating up an inclined plane, so what are the forces acting? Is there is a tension in this direction, there is a weight in this direction, that's it. No more forces are acting. Okay, so option B is the right answer. Only two forces are acting. One is the tension and one is the weight vertically downward. Now question number 8. An object is traveling with velocity 5 meters per second and object accelerate to 15 meter per second in the same direction. What is the variation with the time? The acceleration of the object. Now acceleration of the object, if we want to find out what we can variation in with time of the acceleration. So first of all, acceleration is 15 minus 5, okay, and with respect to time, so if you look at the change in velocity or acceleration into time is nothing but 10. So 10 is what? The change in velocity. So you just look acceleration versus time graph. So the area under this we have discussed, area under acceleration versus time graphs gives you change in velocity. Now you just have to see which area is equals to 10. So this is not, this is not, this is 20, this is the only area. So option D is the right answer, as simple as that. Because the acceleration versus time graph, acceleration into time is change in velocity. So the area under acceleration versus time graph gives you change in velocity. Okay. Now question number 9. Theta is the angle between a ramp and a horizontal surface slowly increases from 0. Okay, this is increasing. An object on the ramp does not slide as theta increases. The friction force on the object. So I think you have already know this. This is mg. This is mg. This will be theta. This will be mg cos theta, and this will be mg sin theta. So if friction is not friction force on the object. So if I want to, friction is what? Nu into n. So nu is the coefficient of friction, n is the normal force, which will be mg cos of theta. So friction is equals to nu mg cos theta. Okay. So we know that if it is not sliding, it means the mg sin theta is equals to friction, because it is a self-dependent force, auto adjustable. So if it is not sliding down, an object on the does not slide down as theta increases, it means that friction is proportional to sine of theta. This is the limiting friction. Limiting friction, maximum friction that it can act. Okay, but as the theta is increasing, the friction will also increase. The maximum friction can act as nu times of mg cos of theta in this case. Okay, so this will be the case here. So it is proportional to the sine theta, not cos theta, guys. Or you can understand like the friction will act in this direction, and as the theta increases, this force is increasing, right? So with increase in this force, friction will also increase. Are you getting my point? Friction is a self-adjustable force, so it will increase with respect to mg sin theta, not the mg cos theta. It is proportional to the sine of theta. So this is a good question. Now question number 10. Now in case of question number 10, these type of question, always when they are moving or when it is released, there is a motion between the objects, always use the principle of conservation of momentum, guys. This you have to think in that terms. Now look at this question is compressed and placed, two stationary masses are given. The mass M, capital M, is twice of small m. The spring is released so that they move in the opposite directions. Now kinetic energy of M and kinetic energy. So we know that initial momentum is what? Initial momentum is 0. So let us say this moves with capital V, this moves with small v. So can I say mv is equals to capital mv, because principle of momentum says that total momentum before and after should be, before was 0, so after they have to move in opposite direction. Now if I try to find out the relation of the velocities, capital M and can be written as 2 small m capital V and small m and v. So this gets divided. So small v is equals to 2 times of v, capital V. This is the velocity with capital M. So half m v square upon half capital M capital V square. Just put up the values, half m v square upon half, capital M is 2m, and capital V is 2, small v is 2 times of capital V square. So like this. So half m gets cancelled. So this is 4 capital V square upon 2 capital V square. This is 2. So answer is C. Okay, so I hope it is clear now. Just use the relations and put up the values, whatever the variables you are getting. Now this is the most important question, number 11. Now I hope majority of you were not able to do this. Now the question says that there is a capital mass m which is accelerating vertically upward by a motor at a constant acceleration. Now object is initially at rest. Okay, this object is at rest and reaches a vertical speed of 4 meter per second in 2 seconds. We have to find out the average power output of the motor. Now average power output of the motor, like how much power output is there for the motor, and power is what? Power is nothing but energy per unit time. So energy per unit time, if I say power is change in energy per unit time. So how much is the energy that is being changed when it is from this to a particular height? So in vertical speed is of 4 meter per second in with a constant acceleration. So can I say that the height or the vertical displacement s equals to ut plus half, or you can say v square equals to acceleration we have to find out first, right? So acceleration in we can say 0 to 4. So acceleration will be, constant acceleration will be 4 by 2, which is 2 meter per second square. Now using the vertical height we have to find out the gain in gravitational potential energy, right? So s is the vertical height, or you can say h. Ut is 0 plus half into 2 into t square, which is 2 square. So this comes out to be 4 meter. So I can say the gain in gravitational potential energy is m, capital M, g into h, which is 4. And kinetic energy is also gained because it increases the speed. So half m v square, v is 16 square, right? So can I say this is how much? This is 4 mg and this is 8 mg. So this becomes how much? Sorry, this is 8 m only. And this g, if I take 10, so this will become 40 m, and this is 8 m, right? So power I can say is, because the answer is in terms of 8 only, so power is 40 plus 8 divided by 2, because time is in 2 seconds. So 48 m by 2, which is 24 m. So the answer is B. So I hope you have got a better understanding of question number 11. Always think in terms of motor. So motor is doing some form of work in order to raise the object. That is the power output. And that work is equals to the energy gain. So energy is gained in terms of gravitational potential energy plus kinetic energy, as it is raising its height and also it is accelerating upward. Okay. So all these questions are the past year paper, guys. Now question number 12 again. Now an object is released from x and slide to y. The vertical distance between x and y is 10 meter. During the motion, 20% of the object's initial gravitational potential energy is lost as friction. We have to find out the speed at y. So what we can do is, can I say half m v square, that is the velocity at y, that will be 20% is lost. So what is gain is the 80% of initial gravitational potential energy. By reading out this statement, can I write like this? So I'm just putting up the values. Half m vy square I have to find out. 80% is 80 upon 100 of total m into g is 10, h is 10. So you can solve this. M and m gets cancelled, 100 and 100 gets cancelled. So Vy square is, or you can put up in G only, that is 8G because G is 10. So Vy is under root of 8G, that can be written as 4 into 2. So under root of Vy can be written as 4 into 2, that is, wait, so this will be 16, right? This is under root of 16 because this 2 will go here as well now. So this will become 16G. So 4G is the answer. 4 root G is the answer, which is C. Option C is the right answer. Okay, so I hope you got a better understanding. Just simply read the question. Now question number 13. A ball 1 is dropped from rest at an initial height of h. Okay. At the same instant, ball 2 is launched vertically upward with an initial velocity u. At what time are both the balls at the same distance above the ground? Now guys, in this type of question you have to understand one thing, what is happening. This is with respect to time, but if I want to draw in reality what is happening. So this is the case that one ball is launched from u with initial velocity u, and one ball is dropped from a height of h at the same time. So what will happen is these both ball will come down and they will meet at a certain point. So the question, at what time both the ball are at the same distance above the ground. So if this is the height h, so it means this has to be traveled h by 2 and this also has to travel h by 2. Are both ball at the same distance above the ground? So same distance means at this position, this is, so this total height is h. So I can say that both the balls have covered the same distance above the ground. So this is h by 2 and this is also h by 2. Can I say like this, right? So we have to find out at what time. So let us say the initial ball h by 2, initial velocity is 0 for the blue one, or let me use the blue color. So h by 2 is equals to ut is half plus 1 by 2 g of t square, and they both are dropped at the same time, right? So and the red one is also h by 2. I'm taking the upward as negative, downward as positive, okay? Because downward is, so minus of h by 2 because it is going upward, then minus of ut plus half of g is acting downward only, t square, right? So we have to find out. So I can say g half gt square is h by 2, right? So this is minus h by 2 minus u into t plus h by 2. Now this h by 2 goes to that side, it becomes minus h by 2 minus h by 2 equals to minus ut. So this will become minus h equals to minus u by ut. Minus and minus gets cancelled. So t is become h by u. So option C is the right answer. So just follow up what is given, draw the diagram, read the question carefully, try to figure out how we can play with the equations of motion. Okay. Now question number D, guys. This is quite obvious. This shows the trajectory of a projectile and the velocity v of the projectile at a given point P. P is located before the projectile reaches the peak value or the maximum height. Air resistance acts on the projectile. The acceleration of the projectile at P is A. What are the magnitude of the horizontal component and vertical component of the acceleration? Now when it is moving upward, guys, it is still moving upward, right? So air resistance will act in the downward direction and g is also acting in the downward direction. So vertical component will be greater than 9.8 because acceleration due to air resistance is acting in the downward, it is in the direction of gravitational acceleration, so it will be greater than 9.8 but acting in the downward direction. And horizontal component of A is still, because it is moving in this direction, right? So horizontal component will be non-zero. So you can say 14, answer will be B, because it will be greater than 9.8, but it will not be 0 because it will oppose the motion. Non-zero will be there. So option B is the right answer. Okay. Now question number 15. So 2 kg block is being pulled by a force of 12 Newton and it is accelerating at 2 meter per second, coefficient of dynamic friction. So guys, this is quite simple. F net is equals to driving force minus resistive force. Simple. So F net, mass is 2, acceleration is 8, driving force is 12 minus resistive force. Resistive force is, this is mg, and friction will be acting in this. So friction is equals to nu into n is equals to m into g. So I can write resistive force or the friction is nu into mg, and g I am taking as 10 for easy calculation. So this will become 20, right? And acceleration is 2. So it becomes 2 into 2 is 4, 12 minus 20 nu. So 20 nu is equals to 12 minus 4, which is 8 by 20. So if you solve this 8 by 20, it will be 0.4. Okay, so I hope you get the answer for 15. So just remember this. This is very important. Question number 16. A person lifts a total mass of 20 kg with a vertical distance of 0.6. The person repeats n times to transfer a total of this. So simple. So mgh times n is equals to 6 into 10 raised to power 4. Put up the values, guys. Simple. M is 20, G is 10, H is 0.6 times N is equals to 6 into 10 raised to power 4. Or you can write 4 zeros, right? 1, 1, 1, 1. So this will become, N will be 600 divided by 0.6 into 2. So this will become 3000 and this will be 500. Simple. So option C is the right answer. Simple calculation you have to do, guys. Question number 17 now. An engine is exerting a horizontal force F on an object that is moving along a horizontal surface. Constant velocity V. The mass of the object is m. The coefficient of friction is nu. Power of the engine. Now we know that power is what? So power is the driving force into velocity V, right? Now if it is moving at a constant velocity, it means the driving force is equals to the resistive force, then only it is moving with a constant velocity, because acceleration is 0. Acceleration 0 means F net 0. F net 0 means driving force is equals to resistive force. So driving force here, can I write down F? It is moving with velocity V, right? And power is F into V. So the mass of the object is an coefficient of dynamic friction between the object. F into V is not given in the option, right? So F is what? F is friction here, and friction is nu into N, and N is what? Mg. So nu mg can be written as F, so I can write nu mg times V. Option D is the right answer. So you have to link what is given and what are the options and try to figure out what could be the best answer. If an option FV is given, then that also may be correct. But we know that this formula is given in your data booklet, so they will ask you in a different way. A model rocket is launched from rest. The graph shows the variation with time t to the net force F applied on the rocket. The average mass of the rocket is given. So guys, look, this is what? Force versus time graph. So always remember, whenever the force versus time graph is given to you, we have discussed this in the class. Force is rate of change of momentum, right? So force into time is the change in momentum. Now change in momentum is mv minus mu. Now it is started from rest, so this becomes 0, so I can write mv is equals to, now this will be the area under the curve. So this area is nothing but change in momentum. So you just find out this area. So this is half, base is 0.5 into height is 20 plus 1 into 10, right? So this is 20, 10, 10 by 2 is 5 plus 10. This is equals to 15. So this is 15 equals to mv, and m is 0.2. So v is equals to 15 upon 0.2, which is 75 meter per second. Okay, so guys, just use whatever we have discussed. That should be very clear, which area under which graph gives you what. So force versus time graphs gives you change in moment. So these all are discussed within the notes. Okay, so if you have not checked, or if you don't have my notes, please check the description or the resources provided. Question number 19. Now there are two masses, capital M and small m, without friction and stationary, at rotates in a horizontal circle of radius given to you. The weight of M provides the centripetal force, okay, that is already given. The time period is 0.5. What is the mass of capital M over small m? Now in such type of question, guys, this is quite simple. So what I can say, the weight mg is equals to the mv square by r. Simple. So it is already given. Read this question. The weight of M provides the centripetal force for the motion of M. So this is the weight provided by the centripetal. So mg is the weight of this, mv square by r. Now you have to just find out m by small m. So that will be v square by g into r. Now how we find out the v square? So v square we can simply find out 2 pi r by t, because v is the linear speed, which is 2 pi r by t. So if you put 2 into pi into r is 0.25 into time period is 0.5. So this is 1, this is 2, this is 1, and this is 1. So this becomes pi. So this is pi square upon g is 10 into r is 0.25. So this is pi square is something 9 upon, this will be 1 by 4, or 10 times 0.25 is 2.5. So this will be something around, if you calculate this, pi square is something 3.14 square, which is 9 point something, so greater than 9. So and this is 2.5. So this will be something around more than 3 and less than 5. So option C is the right answer, best suitable answer. Or you can do the calculation if you want. You will get the nearest answer is 4 only, right? So that is the best way to solve this. Now question number 20. An object is sliding down from rest on a frictionless inclined plane. The object slide 1 meter during the first second. What distance will the object slide during the next second, guys? It is asking you for the next second. So when t is equals to 1 second, the displacement was 1 meter. So when t is equals to 2 second, what would be the displacement during the next second only? So I use s equals to ut plus half a t square, right? So s is 1, initial velocity is 0, so half into a into t square is 1 square. So acceleration is 2. Now the acceleration remains constant, right? So acceleration is 2 meter per second square. So I use s equals to ut is again 0 half a for time from 0 to 2 I'm answering. So acceleration is 2, so half into 2 into 4. So displacement is 4 meter. So the displacement in the next second will be 4 minus 1, which will be 3 meter. So in this next second it will travel 3 meter. Okay, you just have to play with the equation, nothing more than. Now question number 21. A ball is thrown vertically upward at time t equals to 0. The graph shows the variation with time of the height of the ball. The ball returns to the initial height at time t. So this is the trajectory. What is the height h at time t. So we have to find out this height when the time is small t as per the question. Okay, so I can say h is equals to ut and taking the downward direction as negative and upward as positive, right? So ut plus half minus g into t square. So h is equals to ut minus half g t square, right? Now I have to find out in terms of gt, capital T and small t, right? So can I say that, for example, v is equals to u plus at, right? So with initial velocity, whatever be the vertical velocity in the upward direction, let us say the upward direction is positive, so I'm using the initial velocity as u, sorry, v is in the downward direction, so minus v, or v is equals to u, because when the same height, it will be, magnitude will be equal, so minus u is equals to u minus g into capital T. I'm using v equals to u plus at, guys. So can I say from here that gt is equals to 2u, so 2u by g is equals to t. 2u by g can be, or u can be written as, because I have to replace u, so u can be written as gt by 2 from here. So what I will do is I will put u here in terms, because the answer is in capital T and small t. So I write down h is equals to u, instead of u I will write down gt by 2 times small t minus half g t square. Now g by 2 small t is common, so it will be capital T minus t. So option D is the right answer. So just have to play with the equation, nothing more than that. So I'm using the Suvet equations with respect to the vertical directions and considering the sign. These all are important. So if you have any doubt how to consider the directions and all, please check my notes or message me. The descriptions are there for you to solve your doubts or comment below. Okay. Now question number 22. A solid metal is dropped from a tower ball, sorry. A solid metal ball is dropped from a tower. The variation with time of the velocity of the ball is plotted as given to you. Now, in the same way, a hollow metal ball with the same size and shape is dropped from the same tower. What graph will represent the variation with time t, the velocity of the hollow metal ball? Now we have to compare. Now at the same shape and same size, if this is the case, this is the solid metal ball, right? So we have to see, look now here, when it is passing through the same tower, guys. Okay, so if it is hollow, then what we can comment is the velocity will decrease, right? So the velocity with respect to time, as it will reach the terminal velocity more quickly, because the forces will balance quickly, because the weight of the hollow will be less, so air resistance will act and it will balance out the equation more quickly, so it will reach the terminal velocity more quickly than the solid ball. So option C, and this is quite straight, but that will not happen. Initially it will be somewhat similar, because there the air resistance will act, it will take time for the air resistance to act and make a difference. So initially it will be same, but here from the initial only it is different, so D is not the option. A and B will never happen, because the terminal velocity will reach quickly terminal velocity, and that will be the smaller than the solid metal, okay, because they will reach, the forces will be balanced quickly. So option C is the right answer. Now question number 23. A rocket has been just launched vertically from Earth. The images show the free body diagram of the rocket, where F1 represents a larger force than F2. Which force pair F1 and F2 according to Newton's third law? So we know that F2 is nothing but, okay, they are given in this term. Okay, so F2 is the force of exhaust gas on the rocket Gravitational force of the rocket on the earth, force exerted on rocket, and gravitational. So we know that the downward force is nothing but the gravitational force only, guys, right? So gravitational force is nothing but the weight. So F2 is the weight, that is gravitational force, either option B or D. So A and C are incorrect. Now F1 is greater because it is moving in the upward because of the exhaust gases, the thrust provided by the exhaust gases. So option B is the right answer. There is no such gravitational force of Earth on rocket. Okay, this is the of rocket on Earth is in the downward direction, but exhaust gases because of which it is moving vertically upward. The thrust force which is provided in the upward direction. So option B is the right answer. Okay. Now this is again, guys, a good question I can say. A block mass m lies on a table of capital M that rolls freely along the ground. This is free to move. The coefficient of friction between the block and the table is nu. A person is pushing a rolling table. What is the maximum acceleration of the table so that the book does not slide backwards relative to the table? Now, in this case, we can consider both the mass of the table and the book as one because they are considered without slipping. Okay, so for M, I can say if a force has been applied, so there will be a force in this direction. So this object due to its inertia will tend to remain in the same direction. So due to force in this direction, a friction will be acting in this direction. So this will slide, it will tend to remain in the same position. So to remain in the same position and it is relatively moving. So for book M, there will be a friction in this direction. This is important to understand why the friction will, because for this block M, the friction is the only force which is making this possible, and the friction is equals to the ma if it moves, if it wants to move with the maximum acceleration. So friction is equals to the m into a, and friction is nothing but nu mg into m into a. So acceleration will be m gets cancelled, nu times g. So the maximum acceleration so that the block does not move or slide backward will be option B. Okay. So in question number 25, again if you read out the question, there are two things what we can say is they comparing the energies. So half k x square is equals to half m mx vx square plus half my vy square, right? So this is half, this is k, and this is 0.1 square, right? So this will be equals to half, m is 1, vx we have to find out vx square plus half, this is 1 by 4, 0.25, and vy is we have to find out. So this is one equation. So if you solve this, this will be 1 by 2, this will be 1 by 2 common vx square plus vy square by 4. Half and half gets cancelled. So I can say vx square is equals to minus of vy square by 4, or vx is equals to vy by 2. Okay, this I can say, right? So if you look at this equations, what are the supported which can support? So Vx is Vy by 2. So option C is the only option which supports this equation, guys. Okay, so this is the way to solve question number 25. So I hope now you have a better understanding of the MCQ. These all questions are the past year paper questions. If you have any doubt, please let me know.